Hello everyone, this is Gowri HS pursuing my second year BE in the Department of Computer Science and Engineering in Sri Venkateshwara College of Engineering, Bengaluru. Today in this video, let us discuss about the ANOVA technique. Introduction to ANOVA technique. ANOVA stands for Analysis of Variance. It is a statistical method used to compare means among three or more groups. The goal of ANOVA is to determine if at least one group mean is significantly different from the others. Types of ANOVA. There are several types of ANOVA, including one-way, two-way, and repeated measures. The one-way ANOVA tests difference among group based on one independent variable. Two-way ANOVA assesses the influence of two independent variables on a dependent variable. One-way ANOVA. One-way ANOVA is used when there is one categorical independent variable and one continuous dependent variable. This technique helps identify if at least one group mean differs from the other. It does not indicate which specific groups are different. Post hoc tests are required for that. Two-way ANOVA. Two-way ANOVA examine the impact of two independent variables on a continuous dependent variable. This method can also evaluate the interaction between the two independent variables. It is beneficial for understanding how multiple factors influence outcomes simultaneously. Let us see some of the assumptions of ANOVA. ANOVA relies on several key assumptions for valid result. These include normality, homogeneity of variance, and independence of observations. Violating these assumptions can lead to inaccurate conclusions. Normality assumption. The normality assumption states that the data in each group should be approximately normally distributed. This assumption can be checked using graphical methods like QQ plots or statistical tests like Shapiro-Wilk test. If the assumption is violated, transformations or non-parametric tests may be necessary. Homogeneity of variance. Homogeneity of variance means that variance among different groups should be roughly equal. Levene's test is commonly used to assess this assumption. If this assumption is not met, adjustments like Wets ANOVA can be applied. Independence of observations. Independence of observations implies that the data collected from each group should not influence others. This is a crucial assumption in ANOVA as dependent sample can bias results. Random sampling techniques can help ensure the independence of observations. Hypothesis in ANOVA. ANOVA operate under a null hypothesis H0 and an alternative hypothesis H1. The null hypothesis states that all group means are equal, while the alternative suggests at least one is different. The goal of ANOVA test is to assess the validity of the null hypothesis. The F ratio. F ratio is a key statistic in ANOVA representing the ratio of variance between groups to variance within groups. A higher F ratio indicates a greater likelihood that at least one group mean is different. The F ratio is compared against a critical value from the F distribution table to determine its significance. Post hoc tests. Post hoc tests are conducted after finding significant results in ANOVA to identify specific group differences. Common post hoc tests include Turkey's HSD, Bonferroni, and Schiff's test. Choosing the right post hoc test depends on the number of group and the data characteristics. Some of the applications of ANOVA. ANOVA is widely used in various fields including psychology, agriculture, and medicine. Researchers used it to analyze experimental data and understand group differences. It is particularly useful in controlled experiments where multiple treatments are compared. Limitations of ANOVA. ANOVA has limitations such as its sensitivity to outliers, which can skew results. It also requires assumption about normality and homogeneity, which may not always hold true. Additionally, ANOVA does not provide information about the direction of differences between the groups. ANOVA in software. Many statistical software packages such as R, SPSS, and Python SciPy can perform ANOVA. These tools provide user-friendly interfaces for data analysis, including visualization and post-hoc testing. Learning to use software for ANOVA can enhance efficiency and accuracy in research. Interpreting ANOVA results. Interpreting ANOVA results involve analyzing the F statistic and p-values. A p-value less than 0.05 typically indicates significant differences among group means. Researchers must also consider effect sizes to understand the practical significance of results. Reporting ANOVA findings. Reporting ANOVA findings should include the F statistic, degrees of freedom, and p value. It is also essential to summarize group means and any post hoc test results. Clear and concise reporting enhances the transparency and reproducibility of research findings. ANOVA versus other techniques. ANOVA is often compared to t-tests, which are limited to comparing two groups. Unlike t-test, ANOVA can handle multiple groups without inflating the type 1 error rate. However, ANOVA is not suitable for analyzing non-normal data where non-parametric tests may be more appropriate. Practical example of ANOVA. A practical example of ANOVA could involve testing different fertilizer on plant growth. Researcher would measure plant height across multiple groups treated with different fertilizers. ANOVA would determine if there are significant difference in growth attributed to the type of fertilizer. Future trends in ANOVA. Future trends in ANOVA may involve integrating machine learning techniques for complex data analysis. Advance in computational power allow for more extensive data set and sophisticated models. Additionally, the development of new statistical methods may enhance the robustness of ANOVA. Conclusion. ANOVA is a powerful tool for analyzing differences among group means in various fields. Understanding its assumptions and proper application is crucial for valid results. By mastering ANOVA, researchers can make informed decisions based on statistical evidence. Thanks for watching.